Hi, London. So happy to be back here speaking at your meetup after the conference and a bunch of other things. To be honest, I really love this was a real meetup because I can't wait to meet all of you in person. And yeah, I can't wait to be back in the city. It has been more than a year, and I start to get a little bit of cabin fever, and I would really love to be back traveling and meeting you all. Anyway, before we start, I just want to thank for having me tonight. Anyway, before we start, who I am Matteo Collina. At Matteo Collina on Twitter, you might know me from the conference, interwebs, whatever. If you're not, you haven't ever heard of me, follow me on Twitter, pretty please. What else about me? I'm part of the Node.js Technical Steering Committee, the team that maintains Node.js. I'm also part. I'm also the co-creator of Fastify and Pino. I'm work at Nearform as a title as technical director. I'm also a software architect and engineering consultant. So I help companies shipping Node.js. Please follow my newsletter, Adventures in Nodeland, at nodeland.dev. It's I think it's kind of nice, but you might want to decide. You might want to decide for yourself. But check it out. A lot of people have been enjoying it for the last few issues. Apparently, I am a 6 billion download person. I don't know what that means. If I got 1 cent for each one of those downloads, I will be like pretty rich. I'm not getting any, so I don't know. Well, oh, before we go, it's what I'm doing in my role at Nearform. I tend to balance between helping people using Node.js, and working as a consultant with maintaining the ecosystem. So this is always this unstable balance, but it's kind of unique in that sense. So it's a company I really like. By the way, Nearform here, you can see it here. We are hiring quite a lot, both permanent and contractor roles in in the UK and beyond. So just check us out, nearform.com/careers if you are interested. So we are here today to talk about Pino, the fastest logger for Node.js. It has I don't know, maybe minimal features and a great community. It's been downloaded quite a lot, to be honest. If you ever check this live, but there is this nice website called npm stat where you can go and check how many downloads you are getting. Yay, it's 6.5 million downloads per month in March. Anyway, Pino has 4 collaborators and it has version 6. However, we are here to talk about version 7. So this talk, it's really about version 7. Let's do a quick refresher on how Pino works. So Pino is this nice logger that produce JSON and produce new line delimited JSON. So it's a JSON on a line. Very simple. And you can just create Pino and you can just use the logger to log things out. So you can have the concept of child loggers, which are pretty common. So this is the very simple part of the talk finished. Let me do a quick demo of Pino first, so that now we can talk about Pino 7 and what has changed. Now this is called example. So let's open the example, okay? And if we open the example, you can do node example, and you see you get all those lines. Whoa. How can we read them? Well, you can actually read them by using Pino Pretty. And with this, you get a nice output. Cool. Okay. So you've seen how this works. Okay. You've seen that in order to format our logs, we actually connect it to another post processors that, make them pretty nice or change the format. We can have, for example, Pino Elasticsearch to send them to Elasticsearch, for example. So these are my diagrams for Pino V7. So what we have in the iPad? Well, in the iPad we have, you can see that we have this concept of the previous transport, which essentially we were recommending people to run the transports off process, so in a separate process. Why? So you will not block the main event loop to deal with logs. As much as logs are important, the job of our applications is to respond to their clients. So we don't want to block the event loop, block the response, or create additional load to send your logs to Elasticsearch, for example. However, this type of transport system, for example, using Unix pipes, was very complex to run and deploy. Typically, when we run them in on the cloud, what I was recommending was that you run your Node app as a Docker container, and these went log into the Docker logs that then sent to for example, with FileBeat, you could get them to Elasticsearch as before, and Kibana, and then you could access them from Kibana. Pretty neat. However, you could also use, for example, AWS CloudWatch. That was also good as well. These had a few issues though, because for a lot of people running like Node, loading up piping two system together, it was not really useful. They complained a lot. They wanted to run things at the same thing on the same process. So, this was also a feature that was supported by Bunyan, it was supported by Winston, and a lot of people coming from those loggers, they really wanted this feature in. And we always recommended against it because essentially we did not want to create too much burden on the main thread that was also already very busy responding to your clients. The typical behavior when you're doing all these operations in the logger, by the way, it's a huge spike in memory. So essentially, when you were running this type of things in memory, you will see that the memory usage was actually spiking to the roof, which was really, really bad. What did we do? Well, what we did was we thought about this problem and how to provide a better user experience. And we actually divided this concept of the new transports. So, new transports, what do they do? Well, it's inside the same node process, you have your main thread when your main application runs, as well as the worker thread, and then a worker thread where we run all your log processing. This is pretty neat because we can actually differentiate so that we can do a lot of log things in the secondary thread and not block the event loop in the main one unless we really want to. So all of these things can actually work in tandem and produce a extremely good, really good developer experience as well as really good performance. So how does this work? Well, I'm glad you asked. And this is David Mark Clemens. So the first thing that I wanted to show you is a new tiny module called Pino.js ThreadStream. ThreadStream, it's a very simple module. This is essentially you can create your stream, and you require your stream, you create your stream, and then you just specify the file name, the full path of a worker file. This file is going to be used as the worker thread, and we can actually pass in some data in, some options, some more stuff. And this behaves like a string. It has the same API of a string, apart that it only accepts strings. So inside your worker file, you just need to export a single async function where you can just create your destinations, and that's it. That's how you set it up. However, you can support a lot more complex scenario now that you can run things separately. Note that it supports both synchronous and asynchronous flashing, so that one of the tricky bits of the system is that whenever your process is crashing, you might not have a full event loop running. So you might need to do, as it says, a flush or a flash sync. And those things are actually supported by this library, which is pretty neat. So how does this work? Okay, I just wanted to show you briefly. In here, let's see an example. So this is a very simple example that creates a new thread stream. Use join, pass in some worker data, and which processor V is the input from my command line. And then when the stream is ready, we write some stuff to it, and then we call flash sync, and then we are ref. So hey, happy days. So that the process can actually exit. Okay, let's start this. So if I do node create and exit uh, London, here we go. Okay, did nothing, but if we cast London, you'll see that there is hello world. Okay, so I can actually remove London. Cool, right? It's pretty nice. What's in that file? So, well, this is the file that you can use, and it's the same one that it was in the README. And as you can see, we can just create it and call run. Pretty neat, again. Note that you can actually use ECMAScript modules if you like them. So you can literally create import and use your import and export to do the exact same thing that you were doing before without them. So if you prefer this syntax, you can use this syntax as well. Cool. How are you going to use these in Pino? And this is what type of user experience we would like to provide. So, okay, let's see an example. So let's open up the transports. So in this new release of Pino, we create a new logger with called the multi-transport thing. Maybe this API might change a little. This thing is not released yet. I'm talking about pre-release code. I hope you are as excited about it as I am, so that you can contribute and check it out. So what do? We create our logger with files in this multi-transport concept, and we pass in two transports. One, we want to send all the log with level 1 to a file, and all the log with level info to with a print printer. So standard output with some pretty printing outfit. So that, by the way, this is we don't recommend use pretty print in production because it will block the event loop in a not needed way. To be honest, with worker thread, if you have CPU system to spare, probably not is not going to make a lot of harm. But still, don't do it because it will be more costly than what you would usually want it to be. We create those two things. We do some logging, and then the process exits. Okay. So what do? We do node example transports. You will see that all the output get out. And we got a new big log line here, big log file. And I'm going to cut this file. As you see, it has only error and npx pretty print. And yeah, that was probably not a good idea. Come on. Really good. Okay. So as you can see, it only contains those. Cool. Okay. So we can rerun this and it will just work as expected. Note that it is a very interesting part to say. So if we open it up, and at the very end of the script, we do console log example finished, you will see that it actually print example finished at the very first line. Why? Because all the others are being done in the secondary thread, which needs a couple of event loop cycle to be started up and so on before writing it. So hey, just so that you are aware of it, there is that is actually important. So how is this? You might wonder how is this implemented internally, and this is something that I really want to show you because it's actually pretty easy. So in here, what we have the worker. This is the same worker of the ThreadStream worker, and what this does, it essentially it performs some simple stream manipulation to assemble multi-stream, which it's still something that we support in Pino, and it will, it's used to assemble a bunch of streams together as a single destination. So that's what it is. As again, you see a bunch of to-dos because I haven't finished working on this topic just yet. So this is actually pretty simple in the sense that we do some initialization, then we return a function, then use called build on this Pino abstract transport. Whoa, what does Pino abstract transform do? Pino abstract transform, here we go. Oh, maybe the readme is better. Okay, what does Pino abstract transform do? Well, Pino abstract transform, essentially it runs a function build that it simplifies writing transports. It makes writing them pretty easily. So essentially, it combines split2 to process and parse the incoming new line delimited JSON. So how is this implemented? Well, let's see. It's actually very straightforward. We use a split2 and we create to parse the stream. And then for each line, we try to parse the JSON, create objects, set some metadata, and that's it essentially. So pretty great, and it's something that works really well. So we can combine lots of things together, and you will be able to use this utility to write your own transports if you want so. So it's pretty neat. Some other very important bits that I would like to cover before I wrap up is how the ThreadStream is implemented. In order to do so, I will need my iPad because I'm going to draw. I need to draw something. Okay, so let's open. So you have, so ThreadStream, ThreadStream is built on the concept of, it's called a ring buffer. How it works? It works that you have 2 pointers. Okay, so you have 2 pointers, which says this is the write pointer and the read pointer. So the one, so let's say that at any given time we have written till, and then the read pointer would be here, for example. Okay, oh no, this is probably not a good color. Here, okay. So at any given time, we know how much the worker thread will have to read. So essentially, in this situation, when the worker thread wakes up, it knows, oh, I have essentially all this area here to read. This is one of the key parts of how ThreadStream work. So essentially, we maintain those data. It maintains this data structure to be able to constantly synchronize the two streams without never blocking. So they can actually never blocks. Well, that's not true. It can, when it needs, they block when it needs. They need to cycle the ring buffer. So then when it needs to start with the fresh one and move to the previous one, so start from scratch. This is pretty great from my point of view because we can actually communicate between those two streams, those two threads without mostly never block. By default, this is, I think, 4 MB area, which is big enough. You can even make it bigger if you want to. There is also some activity that can be done to improve the efficiency of this data structure. Maybe they won't be made in time for the Pino V7 release. So if you're interested in playing with atomics and this kind of work, like please came back, and I can, I wanted to show a couple more things of this library. as you can see, this it has quite a long piece of code, but one of the interesting bit is the use of atomics weight. As you can see, we do atomics load and atomics weight. So with atomics weight, we wait on this read write index for this value, for this value to change, So it's pretty great. I love it. And on the other end, we do a notify. And when we do a notify, we don't notify to wake up. How we set up the worker thread? Well, we use const worker and we get the worker thread. It's pretty neat because we can just do new worker to execute is the file to execute, and then we pass in the option. On the other end, what we do, we have our worker implementation, and this is what gets executed in the worker thread, and we import your function, your file name, and it creates a little bit of all our state stuff, and then we receive a post message, and then we start running. And in running, we just read the red index. We do some wait diff, which is some asynchronous magic, but we don't. Pretty interesting things again that are happening because the platform still does not have all the things that we need. So essentially, there is not a wait async operator, whatever. Anyway, and then we write up until we can. So I just wanted to show this. Thank you very much for watching, staying with me with this for this talk tonight. Thank you for your time, and please follow me on Twitter at Matteo Collina, and as I said, nearfrom.com /careers. We are hiring quite a lot, all sort of positions. And remember also to go to nodeland.dev and subscribe. Just saying thank you very much. My DMs are open in case you have any questions, also on Twitter, whatever. Bye bye.